Now, in the last lesson, we managed to get our collection of NFTs to display under the section My NFTs. And whenever we mint a new NFT and it gets created, it's going to be loaded up when we head over to this route. Now, the next step is to be able to sell our NFTs if we wanted to, because after all, this is an NFT marketplace that we're creating, right? So we're going to add a little button below each NFT so that we can click on it, set a price, and then get it to be sold on our marketplace, which means it's going to be transferred over to the marketplace, OpenD, so that OpenD can hold on to the ownership. And then once somebody buys that NFT, then OpenD can transfer it to the buyer, and also the buyer's money gets transferred back to us, the owners of the NFT. So a little bit convoluted, and there's quite a lot of code and logic that we have to crack through. So let's get on with it. Now, the first thing we're going to do is we're going to create a button underneath our NFT cards. I want you to go ahead and create a new component for this. In the components folder, we're going to create a new button with the file name of button.jsx. And inside this file, button.jsx, we're going to need to create a functional component, which we're going to call button. And inside this button component, all that it's going to do is to return the HTML, which I've already included for you in the README file. So if you just go ahead and copy it wholesale, everything in there, or if it's easier, you can take a look at it in the preview, because then it gets rid of all these markdown formatting, and you actually copy over the correct parts, which is everything between the open and closing div. And then we're going to paste it inside this return. And I've got an error here because I'm missing my parentheses for my function. And finally, we're going to export default button. Now, this line of code is going to require us to import React. So let's go ahead and copy that from another JSX file. And we can paste it in here. We don't need the useEffect, useState, so we can delete all of that. All we need to do is import React from React. Now here we've got an onClick and we've got a button name. Now this onClick can actually take a function that's passed in through the props. So we could actually have a prop that we pass in called props.handleClick, which will be a function that's passed in here, essentially a callback that will get triggered when this onClick gets triggered. Now that we've got our button created, let's go back to our item.jsx, and below where we've set our owner, set our image, we're going to set our button. And we're going to set it to that new component, button, and hopefully it should import by itself if you select it from the dropdown. And then let's close off that tag and make sure that we pass in the required props. The prop is called handleClick, so I'm just going to copy it over here, and I'm going to set that equal to a function that we've got in here. So I'm going to call this function handleCell, because that is what it's going to do after all. This handleCell is going to be passed in as the callback function, and all we're going to do for now, just to make sure that it works, is to console log cell clicked. And now we've got this set button, but we don't actually have the button created. So I'm going to create a new state tracker called button and set button, and then I'm going to use state to keep track of it. So where is the button going to go? Well, it's going to go just below this final paragraph tag right here. And now if we hit save and we go back to our front end, then you should be able to see these styled buttons underneath each of your NFTs. And if I go ahead and bring up my console and click on cell, then you can see that it says cell clicked every time I click on it. That means we've managed to pass over this function over to our button, and it gets triggered whenever that button gets clicked. So this is a really neat way of working with React when you're passing functions as props. Now, what do we want to happen when somebody clicks on the sell button? Well, we want to be able to give them some sort of way of inputting how much they want to sell the item for. So what we'll need is some sort of input. If you head over to the readme.markdown, you should see a section called the price input HTML. What we want to do is we want to insert it just above our button here. So I'm going to create something called price input. And up here, we're going to track its state. So it's price input and set price input. And now if I copy my price input again, then I want to set it right here. So when handle sell is triggered, it means a sell button was clicked, right? So at this point, we want to set the price input to include this new input. And we want that to show up right here above the button. And we want to create a variable with the let keyword called price, which is going to be used to display the value that has been entered into this input. And we also need to update the onChange to set this price whenever the user types into the input. And in the output section, we're going to set the price to equal e.target.value. Now, normally we would probably use state for this, but because we're going to be doing a lot of asynchronous calls, it's not certain that the state in the input will be updated before we need it to use it to sell the item or to set the price. Now, let's take a look and see what this looks like. So now when we click the sell button, it triggers the handle sell function, which console logs sell clicked, and in addition sets the price input from previously, which was nothing, to this input HTML, which shows up like this. So we can enter a number in here, which is the price in DANG that we want to sell our NFTs for. And now we want to be able to click on this button to confirm our price. That means we want to change this button up a little bit. We want it to have a different function for the on click, to do something else, and also to change its text. Down here, just below where we've set our price input, we're going to set the button to a new button component. We want to be able to pass over the props for the button text, and I want it to say confirm this time. Previously, it should have a text attribute that says sell. And now, once they've set the price, then I want it to say confirm. So now going into our button, we're going to make sure that we replace this hard-coded text with the props.text, which is what we set over here and over here. So now let's try that again. Initially it says sell, but as soon as I click on it, it updates to confirm. In addition, I don't want it to call handle sell again because this time I actually want to make the sale. So I'm going to create another function, which is probably going to need to be an asynchronous function because we're going to be working with the backend in this function to sell our item. This function, I'm going to call it as sell item, and this is what's going to be triggered when the second button click happens. So we're going to replace that handle click here with sell item. And I'm going to console log confirm clicked. Let's try this again. We click sell, sell clicked, and then I put in a price, click confirm, and confirm gets clicked. We can actually access the price in here as well. So if I want to console log the set price, then I can tap into that variable called price right here. And if I click on sell, give it a price, click confirm, you can see my set price is available right here for me to do something with. So what's the next thing I want to do? Well, I want to be able to list this item in my main canister and keep track of it somewhere in a hash map so that I'll know which of these items are listed and how much they're listed for and who it belongs to. So that's what's going to happen in my sell item function. But first, we have to write the logic on the back end. I'm going to create a new public shared function because this is going to allow me to get hold of the caller's ID, which is going to be the user who owns that NFT. And that's going to be really helpful when I set the owner of the NFT in the sale listing. Now I'm going to call this function list item, and it's going to take two inputs. One is the ID, which is going to be a principal type of the NFT that's being listed. And secondly, it's the price as a nat or a natural number, which will determine how much that price is listed for. So the two key pieces of information, right? And what this function is going to do is we're going to create a hash map up here. So we've got our map of NFTs, map of owners, but we're going to create another one, which is going to keep track of all the listings. And that function is going to add to that hash map. We're going to call this map of listings, and it's going to be a hashmap.hashmap. Now the data type of the key is going to be a principal because it's going to be the principal ID of the listed NFT. And the value that that is going to map to is going to be a custom type because we want to hold a bunch of information. We want to hold the owner's ID, we want to hold the price, and maybe in the future you'd even want to hold things like the historic record of sales, what price it was when it first sold, what price it was when it was sold the next time, what date stamp that happened on, and a whole bunch of complex things. But for now, we're going to keep it quite simple, just so that you can see how it's done. So I'm going to create a private type. So this is a new data type that I'm creating here, which is going to be called listing. And this is how you would create a new data type. So you give it a name with a capital letter to begin with, equals, and then a set of curly braces. Now inside here, we get to define all of its properties. So what is the listing going to hold? Well, it's going to hold the item owner, which is going to be of a principal type. And then we close it off with a semicolon. And then it's going to hold the item price as well, which is going to be a natural number. And if we add a semicolon here, then that error will go away. And we can add this listing as the data type of the value. Again, we're going to initialize our hash map in the same way as before, because our principal equal checks for the key equality, and principal hash will hash our keys for us when we create new items. Down here in our list item function, we're going to get hold of the item, the actual NFT, from our map of NFTs. And because we're not sure if a particular NFT actually exists, then we have to do what we did before, which is use this switch statement to unwrap that optional. So I'm going to create a new variable called item, and it's going to have a data type of the NFT actor class .nft, and it's going to be equal to a switch statement that's going to switch on looking through the map of NFTs, calling the .get function, and then getting the NFT with this ID that's passed in. Now we get to specify in the case where it's null, where that ID doesn't exist as a key in the map of NFTs. Well, in that case, we're actually going to return not an NFT, but we're actually going to use the return keyword to output some piece of text. So we can make our function have a return in the form of text. And if in the case where we can't find the item with the ID that was passed in, then we're actually going to exit the rest of the function. We're not going to continue because there's no point. And we're going to return a piece of text telling the front end that the NFT does not exist. That way we might be able to give that as feedback to the user or do something with it. In the other case, where we have the result existing, then we're going to do our usual thing where we say case. If it's a optional result and it does exist, then we're going to return the actual result. And we need some semicolons at the end of all of these lines. And it's angry with us because we don't have a return statement. So for now, I'm just going to return the words success just to stop the error messages from bugging me. So the next thing we want to do is we want to get hold of the owner of this NFT that we are pulling up, because we want to make sure that not just anyone is calling this list item method. We have to check that the person who's calling it, the message.caller, is the same person as the owner of the item that's listed in our map of NFTs. Now, once we've gotten hold of our item, which is our NFT actor class here, we can call that method getOwner in order to check the stored owner of that NFT. So we can say let owner equal item dot get owner. In our if statement, we can check to see if the owner is the same as the message.caller, and using that method from the principal data type equal, we can perform that check quite easily. So we can say principal dot equal, and we can pass in two values. First is the owner, and second is the message.caller. And now if this if statement is true, then that means it's the actual owner who is calling this, which means this is allowed and we can list the item. But if that statement is not true, then that means it's just some random person trying to list somebody else's NFT, which should not be allowed. So in that case, we're just simply going to return you don't own the NFT, which sounds a little bit harsh, but I think it gets to the point. Now, if this is the case, though, we're going to create that new listing inside our map of listings. We can create the new listing item, new listing, and this is going to be of data type listing, and we can set it equal to a new set of curly braces, and we'll set each of these attributes, so item owner and item price. So item owner is going to be equal to the owner that we got back just now, because we've checked that these are the same. And the item price, more importantly, is going to be the price that was passed in over here. And once we've created our listing, we can then put it into the map of listings, dot put, and we're going to put in the key as the ID of the item that's being listed, and the value being the new listing that we created just now. And we can cut this success return to below here, because that's really the only time when it should be successful. And if we add a semicolon here, then that error message should go away. And here it's telling me expression of type async principal cannot produce expected type of principal, which makes me think that this is currently still a promise that's not realized because we forgot, or I forgot, to add the await keyword here. So this should be the final code of our listing, and it does a couple of important things. One is it checks that the person who's actually calling this method to list an NFT is the actual owner of the NFT, because the message.caller has to contain your ID, and we check it against the owner of the NFT. The second thing that it does is it creates this new listing, which seems a little bit overkill for our two pieces of information. But if you were to extend this project, then you would add in the timestamp of the sale, or keep track of the historical prices, and a whole bunch of other things that you could do in here. But now that we've created this function, let's go back to our front end and actually call it. So inside our sell item function, we're going to call that method. So we're going to say await And then we need to call the OpenD canister, which we have yet to import. So let's add that. So import open curly braces, OpenD, and it's going to be from 3 of these dot dot slashes, declarations slash OpenD. Now we can call that method await OpenD dot list item, and we have to provide our 2 pieces of information, the ID of the NFT and the price. So the ID is going to come from our props here, props.id. And the price is, of course, going to come from our price input when we set it here. Now I'm going to save the output as a listing result. And for now, I'm just going to console log it. Like so. In order to test this out, because we've changed the backend, we're going to have to redeploy our canister. I'm going to go ahead and go to my README and scroll up to where I've got the deploy canisters code, and I'm going to copy all of this, paste it in here, and hit enter. Now, once that's all deployed, if we head back and refresh our website, we should have nothing in our collection because it's all reset. So we can mint a new NFT here, give it a name. And once it's minted, we can go over to our My NFTs and click the sell button. So I'm going to set a price on it, click confirm, and it tells me invalid NAT argument 12. And you see how it's got the quotation marks around the 12, which gives me an idea of where the bug might be. Now, I hope you don't mind me showing you all these bugs, because from my experience of building, especially this NFT project, which is really quite big, I've come across a lot of different error codes and a lot of different problems and a lot of different bugs, which, you know, you'll probably make as well. And I think it's quite helpful to see the error messages and have me just sort of translate to you what they mean in case it happens to you as well when you're developing your own project. So in this case, it's saying this is not a NAT, basically. This 12 is a string. So if we go down to the part where we actually passed over the price, if instead of passing over as just a string, we actually wrap it inside this number converter, then it's going to convert it into a number data type. So let's try that again. And this time we're getting our listing success come back, which means that everything actually worked and we've got our newly listed item into our map of listings. Now, what else needs to happen when you sell an item? Well, you need to transfer this item over to the platform, and the platform needs to hold on to it. And the reason for this is because, similar to how we did this check here, making sure that the person who's calling this list item is the same person that owns the NFT, we want to do the same thing in here when we do the transfer function. We want to make sure that we only transfer the item if that transfer function is being called by the owner of the NFT. That's the next function that we have to write, and I'm going to do it at the bottom here. Again, it's going to be a public shared function so that we can tap into the message.caller. And this function is going to be called transfer ownership. Now, it's going to take 2 inputs. One is the new owner's ID. So new owner, which is going to be a principal data type. And this function is going to return a piece of text to let us know whether if the transfer went through successfully. Now, the first thing we're going to do is similar to what we did before, which is to check and make sure that when we're performing this transfer, this method is actually being called by the owner of the NFT. To do that, all we have to do is say message.caller and check that it's equal to the NFT owner, which is set as the owner of this NFT. Now, if this is not true, so if there's an else statement, then that means this person doesn't actually own the NFT. So we're simply going to stop and return. And because we've got this output text, we're going to give the front end an error message and say that not initiated by NFT owner. But inside this if statement, though, we're going to go ahead with the transfer. So the transfer basically involves setting this NFT owner to the new owner that's passed in, which means we have to change this to a var. Now, it's generally not a good idea to leave these global vars lying around where it could be changed by other classes or other actors. So we're going to make all of these properties private. That way, we can only update these properties within the NFT itself. And in the case of the NFT owner, that means only through this transfer ownership function. So we're going to set the NFT owner using that sort of weird syntax, which is the colon equals, to the new owner that's passed in. And once this is done, we're going to return success, so that our front end knows that the transfer went through successfully. Now let's hit save and close down this file and go to our README and go ahead and deploy and update all our canisters using the command line code in here. Coming back to our item, once we've gotten a success back from the listing result. Now, I'm just using text here just to make it easier for you to see what's actually going on so we can follow it sort of roughly in English. But of course, if you want to do this in terms of error codes or success codes or any other way of checking the output, you can. But here, it's pretty clear that if the listing process went through correctly, then we're going to make the transfer. The transfer is going to call a method, the transfer ownership, on the NFT itself. And we already accessed the NFT itself up here when we created that agent and then we loaded up the NFT actor class through this line. So we can simply piggyback off that by creating a new let variable called the NFT actor. And then over here, we get rid of the const keyword and simply assign it to this variable. So that means down here, we can then use it and use our await NFT actor dot transfer ownership. Now the input that our transfer ownership function takes is the principal ID of the new owner. So who is going to be the new owner? Well, it's going to be our OpenD canister. So it'd be great if we get hold of its ID. If we create a new function in here, which will be public query function, and we can call it get OpenD canister ID. Quite wordy again, but good for readability. And then we can return its ID as a principal. Now, as you've seen before, we can use the principal.fromActor method in order to get the principal ID of a particular actor. Then we can simply just write principal.fromActor and pass in the name of this actor, which is OpenD. And if I add a semicolon, then I should get rid of my errors, and I can now go over here and get hold of the OpenD ID. Which is going to be through await OpenD dot get OpenD canister ID. I'm just going to copy and paste it. And once we got hold of that, that's what we're going to be passing in to our transfer ownership as the new owner. Now, finally, because we're going to get a output from this, I'm going to create a new constant called the transfer result to capture the text that gets sent back after this method is called. And as usual, I'm just going to console log it. Now, before we can test our code, we're going to need to deploy again. So make sure that you save both your nft.motoko file and your main.motoko file using Command S on Mac or Control S on Windows. Then go ahead and redeploy your canisters. So again, either heading into the README, or if you click up, it should still be the last command that you had run. Just simply run the deploy so that all our canisters get updated. Now, once it's deployed, we can head over, mint a new item. And if we try to sell it, you're going to see an error right now. So when I click confirm, and now when we try to sell this new item, then it tells you that the error here is failed to verify certificate. So I did quite a lot of digging around this error code, and it turns out that the issue is related to our Dfinity agent. According to the documentation, by default, the agent is configured to talk to the main live internet computer blockchain and verifies the response using a hard-coded public key. But it's not going to work when we're doing it locally. So in order to get around that issue when we're doing local deployment, because let's face it, none of us have enough ICP tokens to be deploying these canisters on the internet computer. Because remember, every single time we're minting an NFT, that is creating a new canister. And if we're doing it live on the internet computer, that's another $5 or $10 for every single time we're testing it. So luckily, we don't have to spend that money. We're doing it locally, and we can simply fix this by going over here and calling agent.fetchRootKey, which is spelt like this. And this is going to tell it that while we're working locally, simply just to fetch the root key and ignore the situation. But it's important to remember that when deploying this project live, we should remove the following line. So now let's try that again, and because our transfer already went through, we'll have to mint another NFT to test it out. And you can just imagine the ka-ching in the background as we've saved ourselves something like $5 or $10 from minting this NFT and creating this canister. So let's try selling this one that we actually own. And once we hit confirm, you should see listing success and transfer success. So we've actually managed to put our NFT onto our hash map of listings, and we've managed to transfer the ownership over to the OpenD canister so that when somebody buys it, it'll be able to transfer it to them. Because remember, the whole point is that only the person who owns the NFT can make the transfer. And because we're not going to be staying around, waiting for somebody to buy it and then calling this method, we have to transfer the ownership when we list it to our OpenD website. So now, even though not much has happened, we've actually written quite a lot of code. So in the next lesson, we're going to tidy things up a little bit, and we're also going to make sure that when we list an item, we're able to see all the items that are listed for sale in the Discover section. So for all of that and more, I'll see you on the next lesson.